Hey guys, so today we're looking at target 2.6, which is using the combined gas law to solve some math problems here. So that means we're not just changing one variable, but we're changing two variables at a time, which is fine because we know how to change one variable at a time. So now we're just adding in that second variable, no big deal, we're just shoving them together. So let's take a look at this problem from your first worksheet and work it out. So we have a sample of sulfur dioxide occupies a volume of 652 milliliters at 40 degrees Celsius. Okay, so I've got 652 milliliters. It says at 40 degrees Celsius. Well, we know we have to convert that to Kelvin. So you're going to add 273, you're going to convert that to Kelvin, and you're going to get 313 Kelvin. Remember, we can't use Celsius because Celsius has negative numbers and there's no negative pressures, so we can't have negative temperatures. So we use Kelvin because there's no negative temperatures in Kelvin. All right, and then we have 720 millimeters of mercury for our pressure. And it says, what volume will the sulfur dioxide occupy at STP? So if you remember, STP, standard temperature and pressure, is 1 atmosphere or 760 millimeters of mercury, because we need to be in the same units, and 0 degrees Celsius, 273 Kelvin. So again, whenever you see STP, that's 0 degrees Celsius and 1 atmosphere. You could change those to whatever units you need, but that is, in general, what STP is. 0 degrees Celsius, 1 atmosphere. All right, so my pressure goes down, my temperature goes, my pressure goes up, my temperature goes down. But the problem is, what do I say for my volume? Because two different things are happening, and they're happening independent of each other. The pressure has no effect on the temperature, and the temperature has no effect on the pressure here. Those things are happening independent of each other. So I actually need to split my volume box in two. I need to know, how is my volume changing in terms of pressure, and how is my volume changing in terms of temperature? It might be the same, it might not be the same. It could be totally opposite, and that would also be okay, because pressure and volume are acting independently of one another. They are only affecting the volume, not each other. So if my pressure goes up, I know from Boyle's law that my volume goes down. So pressure up, volume down. That's Boyle's law, first one we learned. And then if my temperature goes down from Gay-Lussac's law, I know my pressure also goes down, because pressure and temperature are directly proportional. So Boyle's law here, and then I've got Gay-Lussac's law here. Just write GL because his name is very long. So two different gas laws we're using. Again, we don't care about this. And actually I lied, because this is volume. Same relationship. Temperature goes down, volume goes down. Sorry, that's Charles's law. Still direct, still end effect, just gave it the wrong name there, my bad. So pressure and temperature don't affect each other, but a increase in pressure is going to make the volume decrease here, and a decrease in temperature is also going to make the volume decrease. So it makes this one kind of easy, because we know that our volume needs to go down on both accounts. So we're going to set it up just like usual. So I have my 652 milliliters. I'm going to start with pressure. My pressure makes my volume go down, so I need the small number on top. And then if I go to my temperature, you can see I'm just going to add another fraction. I'm going to do the same thing. I'm just going to add on to the problem. My temperature goes down, so my volume needs to go down. So again, I put the small number on top. Now, it could be opposite. In another problem, you might come across where one goes up and one goes down. That's also okay. You just set up your math according to the arrows. All right, so I put that in my calculator. I make sure to put parentheses around my fractions so as not to confuse any order of operations. And I get 538 milliliters. Of course, if I look at my sig figs, I see this pressure here and a couple other measurements only have 2 sig figs. So I need to round my answer to 2 sig figs. So with 2 sig figs, I would get 540 milliliters as my final volume. I come over here. That makes sense because my volume went down on 2 accounts. So this number should definitely be lower than this number. And there we go. That's it. That's how you solve a combined gas law problem.